Don't just copy your nose for the laughs. If I don't say it don't need to be copied, it needs to be copied. Welcome again, once again to the Trigonometry Chronicles. This is Fraser Nation, and we out here. And today we're going to be talking about 11.2, which is 11.5 in the book, Common Logarithms. Your objective today is students will be able to evaluate expressions and solve equations involving logarithms. Now, this is just kind of the setup here. 11.3, we're going to really evaluate expressions and solve equations. But for now, we want to say that anytime there is no number where it should be, like, if you have x, you assume that the exponent is 1. If you have, I don't know, like x, you assume the coefficient to be 1. X to the first power with 1x. You can assume it to be a common number. A log has this as a topic as well. We'll get into that. And you have to remember, logarithms cannot be plugged into the calculator unless it's base 10. So, in case it looks like this, or if it looks like this, okay? E is a special number. We'll get into that a little later. But unless it looks like this, or if it looks like this, we cannot do it in the calculator. All right, next. As I was stating in 11.1, I feel like we need to go ahead and brush this out a little bit more. These two mean the same thing. When you say a logarithmic expression and an exponential expression or equation, the a, the b, and the y are the same thing as the a, the b, and the y. So I just want you to write this down right here. Bases, exponents, and arguments are going to be the same. So down here, I've kind of provided you a key. This base and this base are going to be the same. This argument and this argument are going to be the same. Exponent is going to be the same. So if I had something like log base 9, and this is part of your homework from last time, log base 9 of 9 to the 6th power, the logarithm is always asking for the exponent, okay? So since we don't know what this is, we're going to put a little x right here, okay? So here is my logarithmic equation. And so that would mean what? Okay, well, we have a base already. First of all, we have base. Our base is going to be 9. So here's our base. Our exponent is what the logarithm is asking for. We're going to put an x right here. And then your argument is everything that was inside your log. So this is going to be 9 base 6. Okay, so that's how you really break down an exponential to a log and a log to an exponential. Let's say something like, I don't know, 2 to the x is equal to 5. So bring that back over here. So that's going to mean log base 2, because the base over here is 2. So the base right here is going to be 2. The argument, which is going to be the 5. And then the log always asks for the exponent. So that's going to be this x and this x. Let's move on. It's going to be kind of a short lesson here. So remember, the biggest message is a logarithm is asking for the exponent that you put on the argument. So anytime that there is no base shown for log base x, assume that there's a base of 10. So right there, there's a little invisible 10 that you don't see. So anytime I have something like this, log base 10 of 1,000 is equal to 3. Why? Because this will be changed into 10 to what exponent? 3 is equal to 1,000. Okay, I can do the same thing going all the way down. Log asks for the exponent. So here's your exponent right here. So this is 10 to the second is equal to 100. And so on and so forth down till I get to like right here. 10 to the negative 3, which means fractions, negative expressions. Negative exponents means fractions. So this would be 0.001. So basically this says that you move the decimal to the right 3. This means you move to the decimal to the left 3. So over here I have log base Remember, there's an invisible 10 right here, is equal to y. And so we can kind of change it up a little bit. Log base 10 of 1 is equal to 0. So that means 10 to the 0. Anything to the 0 is equal to 1. Log base 10 to 10. So log base, or 10 to the first power is going to be equal to 10. So on and so forth. So go ahead and write this chart down. And let's go ahead and get on some examples for one time. Well, before we do examples, we got to do change of base formula. Okay, this is the only way that you can put a log that has a different base into the calculator. So change of base formula is used so that you can calculate any base using log base 10 or log base e. You just got to make sure that you put parentheses around everything. So I have an example right here, log base b of m. So the argument goes on the top and the base goes down at the bottom, and this is going to be log base 10. So in the calculator, you would type in log m log b. So for example, here's my example. In case you can't see that, that says log base 5 of 7. So the big number goes on top, the little number goes on the bottom. So this is log base 7 divided by log base 5. So you're going to want to put the top in parentheses and just plug this in the calculator. Log 7 divided by log 5, you're going to get 1.2091. So let's go ahead and do some problems like that. When you put log base 80,000 into the calculator, remember there's an invisible 10 right here. That's the only log that you could put in the calculator, for real. So if you type in the calculator log 80,000, you're going to get 4.9031. Yes? Very good. Number 2, if you get log 0.003, we're probably going to need to have a negative exponent. Remember, this is asking for the exponent. What's the exponent going to be? Okay, and the exponent would be that, but this is the answer. Okay, log always asks for the exponent. This one right here, exponent, so the exponent will be approximately negative 2.5. Ooh, where's my point at? 5229. Okay. And then right here, same thing. We'll probably have a negative exponent for this. This is going to be approximately negative 2.0915. If you think I'm lying, I'm flying, go ahead and plug that in your calculator, and you can pretty much check me on that. If you were to type in your calculator, graphing calculator, 10 to the 4.9031, you're going to get approximately 80,000, okay? So you can do that for the other ones, but I'm going to move on because I want to do some change of base. So here's your change of base right here. So we want to find the value using change of base. Remember, big number goes on top, little number goes on the bottom, and they're going to both be log base 10. But if you don't see it, you just assume that it's log base 10. So we're going to change this to log 18. Okay, remember the big number goes on top. Put this in parentheses when you do your calculator. Divided by log of 12. Put that in the calculator. Okay, so you're going to say log 18 divided by log 12, and you're going to get approximately 1.1632. Yeah, let's go ahead and put a 32 right here. So the problem is really saying, so this really says what exponent, okay? I feel like I keep having to put that in the back of y'all mind. What exponent? So this says, what exponent do I attach to 12 to get 18? And you would say 12 to the 1.1632 is approximately going to be 18. It would be like 17.999999. Okay? Same thing. I'm going to plug this in to the calculator using my change of base. I have log of 15 divided by log 8. Put that in your calculator. This is going to be approximately 1.3023. So remember, again, this says what exponent goes on your base to give you 15. So If I ask that question, this will be 8 to the 1.3023, and you're going to get approximately 15. Okay? So here's your answer right here. Here's your answer right here. I like it. You like it. See y'all next time.